Hello, exceptional students of Mrs. Whitney's. So we're moving on to section 7.5, scale drawings. By now you should have listened to my daughter Brenna explain why scale is important in real life. She is one year away from being having her master's in architecture, so she's used scale for a long time. So scale is a proportional two-dimensional, a scale drawing is a proportional two-dimensional drawing of an object. And she showed you a the big drawing that she showed on the table, and that was a scale drawing. A scale model, if you remember in the front of my room, there's that square thing that looks like a tower and it's got little tubes on it. That's a scale model of something that she had designed. So scale is how you compare real life to the model or the drawing. So we measure things, we have a drawing distance and then we have the actual distance. So the model is always on top and the actual is always, the drawing distance is always on the numerator and the actual distance is always the denominator. It'd be nice if I used mathy words, isn't it? So finding an actual distance. And we used to do this all the time, long before you would use Waze or Google Maps or any of those things. We'd actually get out a map and get out a ruler and kind of stretch it onto the map and figure out what a distance is. So if you look at this map, it says that 1 centimeter is equal to 1 centimeter is equal to 50 miles. So we know that we're going to start our proportion. Remember, a proportion is just two ratios that are equal to each other. So we're going to start 1 centimeter because the drawing is always on top, or the model, and the real life is always in the denominator. So we know that 1 centimeter is equal to 50 miles. So if I measure a centimeter on here, it means it's 50 miles. So we're going to find the distance between Cadillac and Detroit. And since we're looking for real life, we know that the distance goes down here in our proportion. So we're looking between Cadillac and Detroit. So we would measure from there to there. When you had a textbook, you would get out a ruler and measure it. And the distance is actually 3 and 5/10 of a centimeter. So since that comes from the drawing, it goes in the numerator. So from our last unit, you learned that you can cross multiply and you get d times 1, or d, is equal to 50 times 3 and 5/10. And I'm going to whip out my calculator for that. So 3.5 times 50 is 175. So we know that it is roughly 175 miles from Cadillac to Detroit. So that's how you would figure that out. All right, finding a distance in a model. So this is a model of the Earth, and we use these all the time because we can't really get out and start measuring the Earth, and we can't create a real representation of the Earth because then you'd have two gigantic Earths. It doesn't make much sense. So we know that the scale is 1 inch to 500 kilometers. So 1 inch, the model of the drawing is always in the numerator, to 500 kilometers. And the real life is always in the denominator. So we know that has to equal something or other. So the liquid outer core of the Earth is 2,300 kilometers. So that's real life. It goes here. And we want to find out, well, what is it on this little model here? So we would put a x here. And then we cross multiply. 500 times x is 500. X is equal to 1 times 2,300, so 2,300. And then to get x by itself, we're going to divide both sides by 500. And I'm going to, again, use my calculator. So 2,300 divided by 500 is 4. So x is equal to 4 and 6/10. Now we can go back and refer to the original proportion to discover what the units are. So the units would be inches. So it's 4 and 6/10 inches, which is B. And really, we know it can't be these two because those are kilometers, and we're looking for what the model is, and model is not kilometers. All right, so now there's another thing we call a scale factor. And a scale factor doesn't have units. A scale factor would be, say, 1 to 10, which means that it's 1 inch to 10 inches, or 1 foot to 10 feet. It doesn't have units, but if you are comparing it to something that has units, they have to have the same units. So I don't think I showed you the video that interviewed Mr. Whitney, and he was talking about scale factors for HO trains. So HO trains are little trains about that big. O would be what you would think of as the slightly bigger metal ones that Lionel trains are O scale. But HO scale is 1/87th. So 1 inch on a model would be 87 inches on a real locomotive. So we use scale factor in our train hobby. And I'm so sorry Brita is serenading you by chewing on her bone. You're not helping. Okay, so we want to find a scale factor. So we know that the scale model of the Sergeant Floyd monument is 10 inches. So remember, the drawing always goes, or the model always goes in the numerator. And you're comparing that to 100 feet. And we want something in the end which doesn't have any units. So we can't really get rid of the units here because you're comparing inches to feet. So if we have 10 inches, in order to figure out how many inches 100 feet are, you would multiply it by 12, right? That would convert the feet to inches. So that would give us 1,000, oh my goodness, 200. My little guy is not really happy, my board that I'm writing on. So 10 inches to 1,200 inches. And so the inches kind of cancel out because they're the same units. And I'm going to simplify this. So I'm going to divide both by 10 and this by 10. So 10 divided by 10 is 1. 1,200 divided by 10 is 120. So our scale factor here is 1 to 120. So 1 inch would be 120 inches on this monument. 1 foot on a model would be 120 feet on the model. It's just a way to be able to compare without necessarily specifying what the units are. So thanks for watching.